Today's lesson is 8-1, Adding and Subtracting Polynomials. Our objective for the day is going to be to classify, add, and subtract polynomials. Vocabulary. A monomial is a real number, variable, or the product of a real number and one or more variables with whole number exponents.
Degree of a monomial is the sum of the exponents of its variables. The degree of a non-zero constant is 0. 0 has no degree.
A polynomial is a monomial or sum of monomials.
Standard form of a polynomial. The degree of its monomial terms decrease from left to right.
And the degree of a polynomial in one variable is the same as the degree of the monomial with the greatest exponent. Problem 1, finding the degree of a monomial. Question A, we have 8x to the y. X and y both have exponents of 1, and 8 has an exponent of 0, degree of 0, so we will add those up, and we have 2. Letter B, negative 7y to the fourth z. Z has a first degree there. We can add up the fourth plus the first and get fifth degree. And letter C, 4x squared y to the fifth. We have two exponents there that we can just add together. 2 plus 5 gives us 7. It is the 7th degree. Problem 2, adding and subtracting monomials. Now when we work on these, it's just like we were combining like terms from earlier in the year, but you need to remember and focus on the variables need to be exactly the same with the exact same exponents in order for them to be combined. So, question A, we have both terms have x to the fourth power, so those can be combined. Negative 6 plus 11 gives us 5x to the fourth. Letter B, we have 2x squared y to the fourth minus 7x squared y to the fourth. Our variables and exponents are the same, so we can combine those terms. 2 minus 7 is negative 5, x squared, y to the fourth. The third problem, C, we've got 2x squared plus 7x squared. We can add those together and we have 9x squared. And our last problem, letter D, 3x squared minus 4x squared plus 6x squared y. Only two of those terms have the exact same variable and exponents, the first two. So 3 minus 4 gives us a negative 1x squared, and we still have the plus 6x squared y. So now we're going to work on classifying different types of polynomials. So first we have just the integer 6. We know that that has a degree of 0, and we call that a constant. There is only the one term there, and if something only has one term, we call that a monomial. Our second example, 5x plus 9. Our highest exponent is a 1, so we have a first degree. Things that are first degrees we call linear. And this one has two terms to it. And we call anything with two terms a binomial. Our third example, 4x squared plus 7x plus 3. Our highest exponent is squared, so that is a second degree. And we call second degree polynomials quadratics. And this has 3 terms to it, and 3 terms means it's going to be a trinomial. All right, our next example, x to the third power. Our highest term, or our highest exponent is 3, so it is a third degree, and we call those cubics. And this is back to having 1 term, and so it is a monomial again. Our last example, 8x to the fourth minus 3x squared plus 5. Our highest degree is fourth. And we don't have a fancy name for this, so we just call this a fourth degree polynomial. And it has 3 terms to it, and we call those trinomials again. All right, so now our examples. First, we need to put them into standard form, and then we are going to name them based on their degree and the number of terms. So we remember from the definition, standard form of a polynomial, we start with the exponent that is the highest. And we are going to decrease from left to right. So we start off with 8x squared. Our next highest exponent would be 2x to the first. So we add that. And then we subtract 3. Remember, when we are rearranging these problems, the negative signs that are out in front of a number are attached to it. So this is going to be a quadratic, because it's to the second power, and it's a trinomial, because there are 3 terms to it. Okay, example B, we have 6x plus 2x squared. Our highest exponent, our highest degree is x squared, so we've got 2x squared plus 6x. And this is a quadratic binomial because there are 2 terms. Okay, letter C, we have 2 minus 3x squared plus x squared minus 4x cubed. Our highest degree is that minus 4x cubed, so we're going to start with that. Remember, the negative sign is attached to it. Next, we have our x squared terms, which we can combine. A negative 3x squared plus x squared gives us negative 2x squared. And our last term is the positive 2. So this would be a cubic trinomial. Problem 4, we're going to be adding our polynomials. So there are 2 approaches to it, either adding vertically or horizontally. So the vertical method we can treat just like we did systems of equations, where we just add our like terms vertically. So a negative 7.1x squared plus 21x squared is going to give us 13.9x squared. We have a negative 180x plus a negative 140x. So we're going to have 320x, don't forget the x. And 5,800 plus 1,900 is going to give us 7,700.
Make sure that you're lining up your like terms on top of each other.
Okay. Our alternate way of approaching this is horizontally, and we can just combine like terms using the associative property that we have since Chapter 1. So we have no other x cubed terms, so we rewrite 4x to the third power. Now we look, our next term would be an x squared. We have 7x squared, and it's positive. Next up, we're going to take a look at our x terms. We have negative 2x and plus 3x, so that'll leave us with a positive x. We have plus 4 and plus 18, which combine to give us plus 22. Problem 5 is subtracting polynomials. And as we did with systems of equations, we need to remember that negative sign is distributed to all of the terms in our problem. So we have 3x squared minus 4x squared. 3 minus 4 is going to give us a negative 1x squared. Negative 4x minus 3x is going to give us negative 7x. And 8 plus 2 is going to give us 10. So when we approach these problems horizontally, we need to remember that that negative sign is being distributed to all of the terms in parentheses. If it helps to rewrite the problem underneath, feel free, go ahead. So we have negative 4m to the third power. That is the only third power term, so we can just rewrite that. Next up, we have our minus 4m squared. Our next term decreasing will have minus m and minus m, which will give us minus 2m. And our last terms, we have a positive 9 plus 12, which will give us 21. Again, remember to distribute your negative sign to each term. We have 2x squared, or 2x cubed minus 6x cubed. Gives us negative 4x cubed, and you can see Ms. Zierzo is rewriting the second expression under the first so that we can work vertically instead of horizontally. Notice she left a box open under the minus 3x because there is no x term in the second trinomial. So we have negative 4x squared minus 5x squared. That'll give us minus 1x squared. Negative 3x, there's nothing else there, so we rewrite it. And we have the positive 4. And there you have the notes for today.